Geosciences, not PowerPoint.
No, not. We're just fed up of going to open source conferences running on Microsoft, so we thought do everything in open office.
I go to the Mac shop, which runs its cashier systems off Windows, which always makes me laugh.
My name is Saber with my colleague Peter. We are here to give you two case studies we did in Faunalia of using open source tools, GIS tools. Actually, this slide I prepared it using OS Open Data, as John mentioned earlier today. A brief introduction to our company. The first project we are going to talk to you about is Rainforest UK geodatabase and web mapping, and flood mapping and modeling in Saudi Arabia. Faunalia is a European organization. We work on several open source GIS tools. We contribute to Quantum GIS quite heavily. We can find our plugins all free and open source. And we collaborate with OSGeo chapters, local chapters, and that's what we do usually, all exclusively open source. I pass to Peter. He's going to talk you through Rainforest Foundation job we did.
This part of the presentation is going to be a showcase for a project we've been participating in recently. The client is a UK-based charity called the Rainforest Foundation UK, and the presentation will describe their adoption of open source GIS and how that's been useful for them. The Rainforest Foundation UK, as I said, is a charity aiming to conserve rainforests mainly in North Central Africa. They try to achieve this by assisting indigenous people living in the areas of rainforest which are threatened by things like logging concessions, to empower the people, to allow them to stake a claim on the land in which supports them, so supporting their own livelihood in the places where they live. So by doing this, then they stop the governments from being able to just allocate large portions of rainforest to logging concessions for them and become completely clear the forest. So by empowering indigenous people, they're able to protect the rainforest as well as these people's livelihoods. A significant part of their work involves gathering information and data relating to where these people are living, in which parts of the forest, what areas of the surrounding areas they require to support them, such as areas which they use for fishing, for hunting, where these villages are located, and other data such as the population of the village. Obviously mapping comes into this quite heavily because the data that's gathered is then used to create maps and figures used to influence decision-making processes, such as when these NGOs and charities go to talk with governments and other local organisations who are involved in the process of allocating parts of land to either mining or logging concessions. So, as you can imagine, there's quite a lot of data collection involved. So, the process of gathering the data itself is performed with a handheld GPS device, such as a small Garmin device or similar. The main area of operation of Rainforest Foundation UK is the Democratic Republic of Congo, which is a very large country in Central Africa. In order to gather as much information as possible that they require to create these maps, they're planning to train 66 Congolese staff, and each of those staff will then be looking to train another 10 people living in places within these regions they're working. So they're aiming to teach around 660 villages to use the handheld devices to take survey information, such as I mentioned, about their villages and areas which are very important to them to feed and to part of their cultural activities as well. The villages will report details, and then the data is then handed back to Rainforest Foundation's partners in these countries who work out of the field offices. So you can imagine there's quite a lot of data that's actually being collected on the point or track data from GPS devices. Besides working in Democratic Republic of Congo, there are 4 other countries as well. You can see on the overview map of Africa there that they're working in quite a large area in Central Africa. So the problems which Rainforest Foundation have been encountering when gathering this data have mainly been how to store the data, storing in one location. They've been having a lot of problems with data management. Mainly, previously they've been using Esri products, so another one of the main issues was cost of licensing. Because it's a charity organisation, funding is very tight for them, so they're looking for ways to reduce the amount of money spent on licensing software, hence why they were looking towards open source software to start with. But besides the cost of licensing, main problems involve inefficient sharing of GIS data. So you've got people going out and taking survey information. There are instances where this data was copied around to various different field offices. Certain copies of it were updated where others weren't. There was no central management of data, and occasionally there was even data loss, so lost survey information for areas where people had gone out and surveyed, and that no longer exists. The last point there to note that in some of the field offices they are having problems with computer viruses as well, which is probably a minor point compared with the others, but I'll come back to that later, with associated loss of time to replace operating systems on computers and those kind of things. So in terms of their adoption of open source software to try and combat some issues they're having with gathering this data, PostGIS has played an important role in the process itself. I'll describe PostGIS. I'm sure we've talked about this a lot today already in the following slide. A set of documented procedures were created to allow field officers to know exactly how to transfer the data from GPS devices into the PostGIS database. A plugin has been written for QuantumGIS, specifically for taking GPS data from handheld devices and to import it into PostGIS with as minimal interaction as possible with the end user, to try and simplify the process, to speed it up and to reduce the possibility for human error. This deals with things like naming conventions of tables, to try and keep things consistent with the database. The PostGIS database extends and covers all 5 countries, so it houses all of the data. Other parts of the adoption of open source for this particular project was to develop a WMS server to house certain raster data sets which are generated from the survey data, so that field officers can have a connection, for example, can be using QuantumGIS and have a WMS connection back to the central location of all the data. So any statistical analysis that's carried out on the survey vector data can be then viewed in its most up-to-date form in QuantumGIS in one of the field offices. And lastly, PMapper, which is will be discussed in more detail shortly, was used to present a lot of the maps that were generated as part of the exercise, either to the public, to donors, so people making donations to the charity as well as being used in the consultation process with the governments in the countries where they're operating. PostGIS, probably many people have been speaking about this today already. It's obviously a database. The main benefits of using PostGIS for this project is that data is centrally stored in one location and can be managed in terms of you've got field officers who are allowed to upload new data and edit data in a draft area of tables which are kind of in an unapproved state. So the majority of the work editing the data, adding attributes, can be done in one kind of more or less public area by field officers. And because of the ability for you to assign different security levels to different staff and user logins, that data can then be reviewed back in the UK where their main offices are, and then once the data is approved, it can be put into a different location within the PostGIS database, and the permissions can be set then so that people can view the data, but not everyone can edit it. So once something's been audited and approved, it's there kind of protected for most people to only be able to do that. So permissions can be granted in a very granular fashion, which is quite important to the project. The other main benefit of PostGIS is it manages to handle extremely large data sets very, very efficiently. So even with a data set with millions and millions of features located in the UK, we can upload users in remote field offices many, many miles away using quantum GIS. They can make a connection to the database and pan the map around, and the server will only be returning the data that they've requested in the location that they're looking at, rather than quantum GIS needing to trawl through the whole data set to find the points that should be displayed on the screen.